Homework problems, exercise 10F, question 10. The word proportionality has got 9 consonants and 6 vowels, and in how many ways can the letters of that word be arranged so that the vowels and consonants occupy the same positions? If we start by saying the first position's got to be a consonant, there would be 9 choices. The second position's got to be a consonant, there'd be 8 choices. The third position has to be a vowel, there'll be 6 choices because there are 6 vowels. The fourth position has to be a consonant, so there'll be 7 left. The fifth position is a vowel, there's 5 left. Now, I'm not going to continue with that because we can see what's going to happen. For the consonants, we're going to get 9 factorial, and for the vowels, we're going to get 6 factorial if I did continue. If I keep going with that, it's going to be harder to work out the answer and multiply. So we do our consonants times our vowels. With our consonants, we've got 6 repeats, 2 P's, 2 R's, and 2 T's. So consonants is 9 factorial over 2 factorial times 2 factorial times 2 factorial. With our vowels, you've got 3 O's and 2 I's, so it would be 6 factorial over 3 factorial times 2 factorial, and whatever answer you get for that is?
Altogether?
Yep.
27216.
Okay, 2,721,600. Question 11. Part G and H. Okay, it says a form has 10 questions in order, each of which requires the answers yes or no. Now, if you have to fill that form so that exactly 3 of the answers are yes and they occur together, I'd be putting those 3 yeses as a group. So I've got a group of yes, yes, yes. And then I've got the rest of my no's, and there would be 7 no's. Yep. All right. Which other one? All right. So before we even do that, 11A, if you've got a form with 10 questions and each requires a yes or no answer, find the number of ways the form can be filled without restriction. You've got 2 choices for question 1, which is a yes or no, so that's 2 choices. 2 choices for question 2, which is 2 choices. It's going to happen 10 times. 2 to the power of 10 is your answer for part A. In how many ways can the form be filled without restriction is 2 to the power of 10. I might just do 1 or 2 others there. Do you need any others? 2E, if more than 7 answers are yes, so you'd need 8 answers being yes, 9. So E, it says, how many ways can the form be filled in if more than 7 answers are yes? That means we want 8 answers being yes, 9 answers being yes, and 10 answers being yes. So 8, 9, or 10 yes answers. 1 minute. A, 11B, if the first and last answers are yes. So, girls, it's like you're rearranging a word and you've got 8 no's and 2 yeses. So in part B, if the first and last answers are yes. So, yeah. Oh, wait a sec. The first one's definitely a yes. That's 1 choice. And the last one's definitely a yes. That's 1 choice. And then... Oh, yeah, then the others don't have to be. Is that right? Yeah. So the first and the last are definitely yes. That's 1 choice. And then the rest could be 2 choices. 2 choices, yes or no. 2, 2, 2 for the 8 in the middle. No, just 2 to the... Yeah. It's just 2 choices, yes or no. Yes or no. Yes or no. Do you get the idea? So 2 choices times 2 times 2, 8 times. So it's 2 to the 8. Because the first and the last are definitely yes. So girls, it's like you're rearranging a word. You're putting yes, Y-N, Y-N, Y-N. It's because the first one is definitely a yes and the last one's definitely a yes. So there's only 1 choice for those. It's because you already know those answers. All right, if 2 are yes and 8 are no, but we don't know which 2 are yes and which 8 are no. So it's like you're rearranging a word with 2 Y's and 8 N's. That's what it's like. How would you rearrange a word with 2 y's and 8 n's? Wouldn't you do 10 factorial over 2 factorial times 8 factorial? I know you're finding this confusing because you're thinking, why don't I just do 2? Because they're quite different. Because in C they're telling you exactly how many yeses and how many nos there are, and you're just finding the ways of arranging them. But in question B, in 11B, they're saying the first and the last answers are definitely yes, so there's only one choice for those, but you're not sure about the others, so you've got 2 choices for the second one, 2 choices for the third. But in C, it's quite different. They're telling you that definitely 2 answers are yes and 8 answers are no. So you're just finding the different numbers of arrangements of yeses and nos. With D, they are tricky, girls. If 5 are yes and 5 are no, we know that 5 answers are yes and 5 are no, but we don't know the order. So it's 10 factorial over 5 factorial over 5 factorial. E, if you've got 8 that are yes, 9, so we want more than 7 yes, so E is more than 7 are yes. That equals 8 yes, 2 no, 9 yes, 2 no, 1 no, and 10 yes. So 10 yes. So this is 10, so you've got 8 yeses and 2 nos, that's 10 factorial over 8 factorial times 2 factorial. Now this is or means plus, okay, not times, or you've got 10 factorial over 9 factorial times 1 factorial is 1, or you've got 10 factorial over 10 factorial. Now girls, if they're all yes, there's only one way of doing it. Yes, 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 yes. 10 factorial over 10 factorial is 1. If all the answers are yes, there's only one way you can fill the form in. All yes. Does that? So we've got this 10 factorial over 8 factorial, 2 factorial, plus 10 factorial over 9 factorial, 1 factorial, but you don't need the 1 factorial. You only do the factorial for the repeats. And 10 factorial over 10 factorial, or you could say it's just 1, but we know anything over itself is 1. So I don't know what the answers to all these is. What's 10 factorial over 9 factorial is 10, isn't it? And the first one, so the answer is 56. Nice and tricky, aren't they?
Yeah, because like 3 of them are no.
It says more than yes are 7. More than 7 are yes. Oh. All right, F. Girls, an odd number are yes. You would look at your total possibilities for F divided by 2. Because half of them will be odd and half of them will be even. So possibilities. So it would have been 2 to the power of 8 divided by 2. Yeah. Yes. So look, if it's odd and even, it tends to be just half of them. If you've got, oh yeah, 2 to the 10, sorry, not 2 to the 8. 2 to the 10 divided by 2. Because it's all your choices from part A, half of them. G. Now, if exactly 3 answers are yes and they occur together. So you've got, they're a group, and then you've got the other 7 no's. So you're ordering 8 things. Wait a sec. 8 factorial, because you're ordering 8 things over the repeats of the n's.
So 7.
No, 1, 2, 3, 4, 5, 6, 7. So we're ordering 8 groups, yep, over 7 factorial because the n's are all duplicated. So yeah, that is 8. 8 factorial over 7 factorial is 8 times 7 factorial over 7 factorial, isn't it? Which is 8. Girls, the yeses have to be together in one group. It's like we're ordering a word. So the yeses are together. They're like one letter now, one group. So you've got one group for the yeses because they've all got to be together, and you've got the other N's. So it's like you're ordering 8 things now. Those 7 plus this one group makes 8 things to order. But the problem is these are all duplicated, those N's. So you divide by 7 factorial. So you're just trying to order an 8-letter word with 7 duplicates in it. Tricky, isn't it, girls? H. If the first and last answers are yes, so you might want to draw out your positions. So they're definitely yes, so they're ones. Do you know what I mean? And exactly 4 more are yes. So you in here you've got a combination of 4 yeses and 4 no's. But you don't know the order.
Why did you put it over 1?
No, it's not over 1. I'm just showing that there's one choice for the N's. So you're just trying to order.
I wasn't talking. This is angry.
So what we're trying to do, if the first and last answers are yes and exactly 4 more are yes, means that the 4 middle ones, if exactly 4 are yes, then 4 are no. So it's just going to be, so that's got one choice and that's one choice. So it's 1 times 8 factorial, but you've got duplicates in here
4 factorial.
over 4 factorial.
So basically it's just the middle one.
It's just the middle ones. So one choice. I'll be doing a video tonight because we're not getting enough done. Whatever it is. And how would you work that out? 8 times 7 times 6 times 5 times 4 factorial over 4 factorial times 4 times 3 times 2. You know how I showed you yesterday? Swap, cross, 4 times 2 is 8, 3 goes into, it's 70. You can use your calculator. You know what? It's identified by a row of coloured dots on their lids, and the colours used are yellow, green and purple. Now if we want no more than 3 yellow, no more than 2 green, and no more than 1 purple dot. So if exactly 6 dots are used, and you can have no more than 3 yellow, does that mean you can have 3, no more than 2 green, and no more than 1 P means you have to have 3 yellow, 2 green, 1 P, purple.
6 factorial over is a P.
Mm. Now, it's B that's the problem. A is fine because if it's no more than 3 yellow, no more than 2 green, and no more than 1 purple, and you've only got 6, you have to have 3 yellow, 2 green, 1 purple. There's no other choice. So that one's okay. 6 factorial over the repeats, 3 factorial times 2 factorial. Right, B. What is the number of different codes possible if only 5 dots are used? Now, this is where I wanted to start today's lesson. So what you've got to do is cases. First case is there is no Y. So consider cases. There's only 3 cases. We'll miss out a yellow, a green, or a purple. So cases. First case, if there is no Y, we would have 2 yellows, 2 greens, and a purple. Or we could have no green. If we had no green, what would we have? 3 yellows, 1 green, and 1 purple. Or we could have no P, purple, 3 yellows and 2 greens. Now you do each of those and add them because it could be no yellow, or you could have, because we're only choosing 5 out of the 6 possibilities. So the cases are you could have no yellow, you could have, see you've got the 3 colours, you could either be missing the yellow, or you could be missing the green, or you could be missing the purple. I'll read the question again. Containers are identified by a row of coloured dots on their lids. The colours used are yellow, green and purple. In any arrangement, there is to be no more than 3 yellow dots, no more than 2 green dots, and no more than 1 purple dot. What is the total number of different codes possible if only 5 dots are used? Now, 5 dots are used, you're either going to miss out on a yellow, a green, or a purple, so we do it in cases. First case is no yellow. What's the combinations for that? 5 factorial over 2 factorial, 2 factorial, which is?
30.
The second one is 5 factorial over 3 factorial, which is? And the last one is 5 factorial over 3 factorial, 2 factorial.
10.
So adding them together is 60. There was another way to do it, but I don't know this along your lines.
I didn't do it.
But we'd have to see for a very large number of questions if it works. I tried this and it worked. Or 6p5 over the repeats. I'm not too happy with it, but it works. It works. 6p5 over, so you've got 6, you're choosing 5, but there could be 3 repeats or 2 repeats. The thing is, I think it takes into account missing out the P, the G, or the Y, and it works it out. Because if you do this, 6p5 is, help me, on your calculator, 6p5 over 3 factorial is 6 and 2 factorial is 2. 720 over 12 is what?
60.
So keep this one in mind. I believe it will take into account all the cases and it works with the next few questions as well. It's 6, choosing 5 in order, but then there are repeats of 3 and 2. It seems to work, or the cases definitely works. So what we're going to do, each time we get one of these, we'll do the cases, then we'll try this other method
And see if it works.
All right, question 13 is the same. How many 5-letter words? So how many, girls, I'll be doing combinations by video tonight. How many they're easier. How many 5-letter words can be formed using, can you just have the question book in front of you? Using the letters of the word stress. This is the same thing as what I've just done. Question 13A, and you can do B yourself for homework. How many 5-letter words can be formed from the letters, using letters of the word stress? We can do the cases. So if we do the cases, what are the cases? You're missing an S or a T or an R or an E. But you know, missing a T, R, and E will give you exactly the same answers. So because if you're missing a T, you've still got the 3 S's and 2 other consonants, 2 other letters. If you're missing the R, you still got 3 S's. If you're missing the E, you still got 3 S's. So cases, if you are missing, I'm going to do them together. Let's go missing an S.
So that's case
If
1.
you're missing an S, so case 1 is missing an S, you would have TRESS. Can you arrange it? 5 factorial over 2 factorial. That's the first one. And I'm going to do cases 2, 3, and 4 would be missing a T, R, or an E. Let's just say you're missing a T. Wouldn't you have SRESS? If you're missing an R, wouldn't it be STESS? And if you're missing an E, wouldn't it be stress? Do you get it? So, what's the answer for the first one? 5. Oh, this one, was it 60? Is that 60? All right. If we're doing cases, if you're missing the T, then the R, then the E, 5 factorial over what?
3 factorial.
Now, isn't the next one the same? 5 factorial over 3, 5 factorial over 3. Why don't I just do them all together and say I got 3 of those? Because I'm doing that plus itself again, plus itself again. Do you understand why I'm timesing it by 3? I'm going to get the same answer twice. It's like doing 2 times 3. 2 plus 2 plus 2 is the same as 2 times 3. Do you understand why I'm doing this? Because I'm going to get the same answer 3 times. So what's 5 factorial over 3 factorial?
20.
20 times 3, 60. The answer is?
1.2.
Now, you know how I said let's try that other method? The quick one with the P's? How many letters have I got?
6.
Or 6. How many am I choosing?
5,
And how many repeats in the whole thing?
3.
Does it work? 6p5 is 720 over
3 factorial.
6, 120. It works. Might consider it. Hello.
Do you have lunchtime meetings today?
So here we go. A permutation describes an arrangement of objects in a certain order. The notation for permutation is NPR. So NPR is the number, you know how we've done permutations before? It's when order matters. So NPR is the number of arrangements possible for an ordered selection of R objects from N objects. So I might say I've got 6 objects or 6 letters and I want to see how many 4-letter words I want to choose. So I'd go 6p4. Remember we did permutations when order matters. That is, if I write the letters AB, they're different to writing the letters BA. So they're different as they are in a different order. So girls, the main thing is permutations describe an arrangement of objects in a certain order. In other words, for permutations, if you're ever using that P button or that 10 times 9 times 8 times 7, something like that, order matters, okay? It's like if I say 8 people entered a race, in how many ways can first, second and third place be achieved? You'd go 8 people could get first, 7 people could get second, 6 people could get third, or that's 8p3. Okay, same thing. Now, what we're doing today is when order is not important. What were you asking? That is, A, B and BA are different as they are in a different order. When order is not important, that is, when AB, that's a B. So when AB and BA mean the same thing, the number of arrangements is called a combination. Now, I'll give you an example. There are 21 people in this class. If I choose 5 of you to go and help me carry something to my car, does the order in which I choose those 5 people matter? Okay. It doesn't matter. It's not like so it doesn't matter which 5 I get as long as I get 5 people. So it wouldn't be in order, okay? So that's when order doesn't matter. If I just need a group of people from a bigger group of people. The order in which I chose you doesn't matter. But if I'm choosing 5 leadership positions and all those positions are different positions, then order does matter. Because a president's different to a vice president, different to a secretary, etc. Okay? So it's like with the SRC. How many people in it? In the top, no, it's more than 12. But you know how you've got those those roles, specific roles? Like the 3, the president. That's different to, if I want to choose who's president and vice president's, order matters. Because the president's different to the vice presidents, all right, even though there are 2 of them, but whatever. All right, we'll do more of these as we go on, all right? So when order is not important, that is when A, B and BA mean the same thing. The number of arrangements is called a combination, hence our topic, permutations and combinations. So permutation, order matters. Combination, order doesn't matter. You're just making combinations. Investigation. Find the following numbers of unordered arrangements. If I want a committee of 2 from 5 people, I know this is really messy. So I've got person 1, 2, 3, 4, 5. So girls, you know how you use P for permutation? On your calculator, you use the C button and it would be 5, choose 2 people. C means combination, but it also means choose. I've got 5 people that I can choose from. I need just a committee of 2 people. There's no special positions in that committee. It would be 5 people, choose 2. Now let's see our arrangements if you did them in order. 1 and 2 would be an arrangement. 1 and 3, 1 and 4, 1 and 5. Got those? Then we could have 2 with 3, 2 with 4, 2 with 5. That's those. Then we could have person 3 with 4 or 3 with 5. and then lastly persons 4 and 5. Girls, I don't need to then do person 2 with 1, and then person 3 with 1, person 4 with 1, person 5 with 1. I don't need to then work it all out backwards. Okay? So there are just 10 different ways that I can choose a committee of 2. Are there any duplicates there? No. But I don't now write, I could have chosen 2 first and then 1. It's not needed because I just want 2 people from that group. It doesn't matter the order in which I choose them. All right? So it's not 5 times 4. The answer's not 5 times 4. You would do 5 times 4 if order mattered. But we don't. It's just 5 and I want to choose 2.
10 ways.
10. 10 ways. Number of ways is that which equals 10. I know. It's the C button. So you're just choosing. If you think you're just choosing and not ordering people, it's just C for choose. Use the choose button. If you want a committee of 3 people from 4 people, I want a committee of 3 from 4. Girls, obviously, so you've got person 1 with, we've got 1, 2, 3, 4. They're my people. I could have people 1, 2, 3. I could have the first, the second, and the fourth person, the second, the third, and the fourth person, or the first, the third, and the fourth person. In other words, in each committee, 1 person misses out. So there's 4 ways of doing it, which is 4 choose 3. Now, I'm not going to talk about this other bit yet. But to do 4 choose 3, there's a different definition for choose. Yeah, just do that at the moment. 4 choose 3. If you want a committee, don't worry about this other bit yet. I'll do it tomorrow. If you want a committee of 3 from 5 people, it's going to be 5 choose 3. But here are my 5 people. People 1, 2, 3, 4, 5. If you wrote out all the combinations, 1, 2, and 3, 1, 2, and 4, 1, 2, and 5, 2, 3, and 4, 2, 3, and 5, 3, 4, and 5. So I'm going 1, 2, 3, 1, 2, 4, 1, 2, 5. I'm doing 1 and 2 first. Then I'm doing people's 2 and 3. 2 and 3 with 4, 2 and 3 with 5. Then I'm doing 3, 4, 5. Then I'm going to miss out person 2. 1, 3, and 4. 1, 3, and 5 is there. Then I'm going to miss out some others. 1, 4, and 5. 2, 4, and 5. They're all the possibilities. You wouldn't be able to find any more. But the quick way to do it is just 5 choose 3. What's 5 choose 3 on your calculator?
5 second function 5.
What did you get? 10. So I'm listing them, but I'm doing on my calculator 5 choose 3. I know you're looking at this and thinking, what's that mean? Don't worry about it today. If you want a committee of 5 people from 4, it's just going to be 5 choose 4. Or, common sense, each person misses out. Person 5's not here. Person 4's not there. Person 3's missing here. Person 1's missing there. And person 2 is missing there. 5 ways. 5 choose 4. If you do it on your calculator, it's also 5. Do you get it? Now, girls, here's the definition. The number of ways of making unordered selections of R objects from N objects is given by the following: little n, C, R. You know how we had NPR before? Now we've got NCR. So if order doesn't matter, choosing just a little group of people from a bigger group, it doesn't matter which order I chose them in, they're still my new group. You use the C button, N choose R. Okay? Girls, I'm swapping over. Now, what I'll do, this I'll do tomorrow. Not going to do that now. All right? Let's just do one question. I'm going to make you do the exercise.
Is 10G miss?
10G. Do you want me to do a quick video? It'll be 10G.
30 seconds.
I don't know. Shh.
Why don't you just email us later?
I'll email you.